So first we're going to take economics. And I'm just going to start with the question on your left, and then we'll go to the question on your right, and I'll look for some answers. So on the left, a girl decides to wait in line all night to be the first to get a new game console. And then there's this little table of the costs that were involved in that whole enterprise. So she got a sleeping bag last year for camping. She brought that along while she waited in line. There was a bus ride that she had to pay for to get to the store. And then there was some lost income from her part-time night shift job that she decided not to go to so she could wait for the console. And then there was the cost of the console itself, which is $500. So here's the test question. Which of the cost items, A through D, are what you call sunk costs? So I'm going to hold up my watch here, and I want you guys to call out which one is it. Okay. Okay, so what's interesting here is a lot of you know right away, hey, I don't know what a sunk cost is. I don't remember that. But you know it right away, that you just don't know it. Did anyone know that A is the sunk cost? We have a few hands up. Okay, maybe they did change the name. I'm not sure about that, but okay. Exactly. But those who got the answer, did you kind of know it right away? Okay. So let's go to the other one. Benjamin wanted to go to a baseball game when his favorite team was playing at home. He was quite upset when he found out that all the tickets were sold out. So the game night, he approached scalpers who were selling tickets on the sidewalk. Benjamin asked a few scalpers how much they wanted for a ticket. The first one wanted much more than the original price. So Benjamin asked another one, and that person wanted even more. So he kept on asking around, and he got different prices. After an hour, it was getting closer to game time, and he saw that the prices were not lower. He went back only to discover that the first seller had doubled the price. So here's the test question. Using economic terms and reasoning, explain why the prices of the tickets went up. Okay, so everyone's saying supply and demand, but you have to explain. And I'm just going to say, wouldn't that take a little bit longer to do than the first question? And so there's a different feeling as you're answering these questions. Let's look at one in biology. Okay, so starting again on your left side, what biological process does the following formula represent? Photosynthesis. It's a metabolic process, that's right. It's cellular respiration. So same thing, you kind of knew right away, I think I have it, or no, I don't have it. Let's look at the other one. Louise, one of the benefits of designing tests is sometimes you use your own name and your test items. So anyway, Louise, a 9th grader, was assigned to do an experiment for her biology class. The experiment involved planting wheat seeds in 3 different conditions, and you can see the conditions there. I will read it out loud in case you can't. A, light and no water. B, light with water. And C, no light but water. So, look at the check boxes beneath each of the pictures of Louise's wheat seeds and seedlings. Check the processes that are occurring. You may check none, 1, or 2 per dish. And the processes, in case you cannot see them, cellular respiration and photosynthesis. So again, try to think about it. You guys, what are you feeling about this item? Is this going to be something you kind of know right away? Is it going to take a little time? Take a little time. Okay. So our hypothesis, I'm going to talk a little bit about what's going on here psychologically, and in terms of that knowledge network that experts have. So the first questions, the ones you saw on the one side, your left side, you have that knowledge network, and all we're asking you to do is, bing, go in and pick one piece out. Just get one. And for the second question, we're asking you to really have to search that network and link things and link ideas. And you have to understand all the relations. So it's a much more, you're navigating the knowledge network a lot more. That's why it takes a bit longer. So our hypothesis is that most college tests, particularly the ones that are published out there, emphasize questions more like the first one. And the reason is because they're a bit easier to grade. They're a bit easier for students to do. And it makes a lot of sense. If you really want to differentiate people who are proficient in a field from those who are not proficient, well, all you have to do is sort of sample a lot of little bits of knowledge. Just take a lot of little bits, throw them together, and then those who are more proficient will tend to know more of they'll be able to answer the questions more, right? So that's a pretty good indicator. You can see why that's a pretty robust system. But our sense of this is that you're missing an opportunity. You're actually encouraging a certain kind of learning, which is I just have to memorize as much as humanly possible. The problem with that is that doing all that kind of cramming for the test decays very quickly. You're just not going to learn it very well. So the more robust way to test them and to get them learning is to get them to apply the ideas, okay? So we want to make a test that gives students an opportunity to do that. So we prefer to at least integrate some more questions of that nature. In our tests, for research purposes, I want to put this out there right now, they were short answer constructed response. And I'm going to talk more about the limitations of that in the real world. But we did that for research purposes, and you'll see why. We understand a lot more about how to create those kind of items as a result of this design. So we call our approach Think Like an Expert. And in our test, in our study, the way we did it is we designed a couple of prototype tests. We call them domain-specific assessment also, that's another name. We designed them in biology and economics. We used a certain approach. I'm not going to get into a lot of detail, but I'm just going to say it's the secret sauce here at SRI called evidence-centered design. They use it at places like ETS too. So you get a little taste of how that works. And we also use cognitive science to inform the design of these. How do people actually learn some of these ideas? There's tons of research on some of this. And so we actually used it in the design of the items. So after we created our test items, then we wanted to conduct validity tests to see how well they work. And the way you do that, there are two things you're really trying to find out with validity tests. You want to see, do they work? Do they work with students, real people? That's one question. The other question is you compare the prototypes to existing tests that are out there. And so the tests that we were comparing ourselves to, if you remember that graph, remember I told you there were some tests that were a lot focused on critical thinking, and then there were other tests focused on how much have you memorized from the field. We compared ourselves to one of each. Okay. So I'm going to talk a little bit more about that. So what are the benefits to that approach? We think there are two. First of all, look at the evidence bullet there. We're finding out if what we're doing actually works. And we're giving you some evidence of whether it works or to what extent it works. And then, part of evidence-centered design, and a part I'm not going to talk a great deal about tonight, is we are documenting so much. Every step of the way, we are documenting our decisions. And that stuff is really useful. It's reusable. You can go back, and when you get your validity results, you can see what wasn't working in the test, make a small adjustment, and inform the design and improve it. Okay, so now I'm going to get into the research design, and I'm going to, again, not focus too much on the details of the methods. You'll get a little more of that later. But I really want to focus now is on our research questions and kind of why we're asking them. So the first research question is what kinds of domain knowledge and skills are being measured by tests, current tests out there in college economics and biology? And so, how does ours compare? So it's our contention that most of these tests are really focused on recall and not on understanding the big ideas and how you apply them. Okay, that was our thesis, and so we wanted to test that out. And there are a couple of ways you do that. The alignment study and the correlational study. The alignment study, I'll go into more detail later, but that's the one where people are holding up ratings, okay? And essentially you get a group of experts to look at your tests and the other tests, just looking at the prompts, the questions, And I'll talk more about what they do, but they'll rate the kind of knowledge that you're actually going to be eliciting. Then the correlational study is when you give the tests, all 3 tests, to a group of students, and you see, well, how much does a student's performance on one test relate to how they do in the other 2 tests? And I'll explain more why that's important. It tells us what we're doing. So the second big research question is what they call the sensitivity question, and I have the radar, the satellite dish out there. How sensitive are our tests that we're developing, and how sensitive are those other tests that we're comparing ourselves to what it is students actually learn in a classroom, right? Now, why do you want to ask that? Because we can all go home if we're not testing anything that anybody's learning, okay, in an actual classroom. And the way we do this, again, is we stratify the students. We take some students who have only had basically high school classes, no college. We take some students who've had a little bit, and then we take students who've had the full complement in those first 2 years of college. Because again, we're focused on the non-majors. And we compare how they do. You'll see that later. And finally, it's what I call the duck question. You know, does it walk like a duck? Does it quack like a duck? This is where we really take a good look at how students are answering our test questions. And we want to just find out, did we actually get them to do the things we wanted them to be doing? Are they thinking in the ways we wanted them to be thinking? And are they using the ideas that we wanted them to be using? And that's a really interesting process called cognitive analysis, and I'll talk a bit more about that too. So here's the lightning round on evidence-centered design. As I mentioned, this is what we call our secret sauce. There's a whole lot more to this, but I'm just going to give you the highlights. Basically, those 2 big bars are really the heart and soul of what evidence-centered design is. Domain analysis, domain modeling. And those little boxes underneath are all parts of domain modeling. But in a nutshell, in plain English, what is this? So domain analysis is when we actually go to talk to the experts, and we find out what their sort of mental map is, but then we also get them to calibrate and say, well, what's the mental map of the students, right? And so we actually say, this is all the knowledge, and these are all the kinds of skills that you want them to have, right? We put it in a map. And that's domain analysis. Domain modeling is when we actually sit down and we develop an architecture for assessments that will help us to measure that knowledge. And I'll talk a bit more about that process. But here's a snapshot of domain analysis. Basically, it's a kind of a concept map. This is what it looks like to be an expert in algebra. I'm not going to go through all those little squares. It's complicated. There's a whole lot for people to know. And it's all linked and so forth. So when we had to talk with experts in biology and economics to sort of probe what it is they know and what's important, we had a sort of a shorthand for categorizing the knowledge they have. And this is the shorthand, and it's based on some work by Rich Shabelson at Stanford. But basically, there's just the facts, that's declarative knowledge, and then there are all these little step-by-step procedures, and that's what you call procedural knowledge, and you gather a whole bunch of that stuff together, and you put it into the knowledge network, and that's the schematic, right? That's the schema. But schematic knowledge is your ability to navigate that knowledge network and to know the relations among all those different ideas. And strategic knowledge, which is on the far side there, is when you go look at the real world and you know that situation, this idea that I have in my mental map applies to that situation, will help me understand it and help me solve a problem. Now I'm looking around the room and I'm sensing a sort of, does anyone want to ask me a question at this point? Yes?
I looked at the idea of testing at high school and then after 1 or 2 years and then so forth. How do you control for the variables like who's teaching the course?
Oh, very good question. And we are not in that world. I'm just going to put that out to you right now. We're in the design world. And so that's an excellent question about when you get the results of the test and you're trying to understand why is it that students are learning effectively here and less effectively there. Obviously, one of the big inputs there is the teaching. That's an absolutely true point. Are there any other questions about this? I just sensed there was some puzzlement or something. Go.
I've heard the word cognitive used to replace schematic. So you get cognitive, declarative, and procedural. But I think it's the same thing.
Well, I mean, I guess this is a distinction. I personally see cognitive as this is all part of cognition is how you learn content, as opposed to affect, which is your sort of feelings. Often there are these distinctions between cognition and affect. And so anytime you're talking about content, you're talking about cognition. But what you see here is a kind of set of categories for parsing different kinds of knowledge that have different purposes. So declarative, that first question that I showed all of you guys, that was a declarative test item. It was just asking you to go out and get one little factoid, right? Whereas the second test questions that I was showing you, that was a much more either schematic or strategic, where we're asking you to navigate the network a little bit. So the knowledge we're asking you to sort of bring forward is more complex. And I hope does that make sense to folks? Okay, I'm going to move on then. All right, so I just wanted to give you a snapshot of this is what a college sophomore is expected to know about energy flow and matter cycling in biology. All right? And I don't know how that strikes everybody, but it strikes me as a lot to know. And in particular, what's hard about it is all the little connections and things. I'm not going to go into all the details, but this really is what they teach them. How about economics? What is a sophomore in economics supposed to understand about supply and demand and the markets and so forth? This is pretty much it. And they're supposed to do a lot of different things and a lot of manipulations. They're supposed to be able to graph it. They're supposed to be able to talk about it in narrative cases. So you're starting to get the sense in a snapshot of how complex this stuff is, and you're also starting to get a sense why maybe you only have half the pie or a few puzzle pieces once you get out of college, right?